These are limit switches. And a limit switch is just a basic electromechanical device that switches electricity whenever a direct object comes into contact with this actuator arm, like that, and the switch closes or it opens. And limit switches can be used for many different types of control applications, but just to name a few, I've seen them used as machine positioning, such as if the machine would over travel, it would hit the limit switch, it would notify the machine that, hey, you over traveled. It also lets the machine know that you are at your home position when it would hit the limit switch. The limit switches can also be used in many different types of variety ways for control applications. So on this particular limit switch here, we have two sets of contacts. We have a normally open set of contacts and a normally closed set of contacts. And then if we open up this limit switch, you can see here the set of contacts that says NO and NC. These are your normally open, and NC is the normally closed. So in this normal state of the limit switch, if there is no object that comes and actuates the actuator arm like this, your set of normally open contacts would remain open, meaning there is no pathway for electricity to jump from this terminal to this terminal. Your normally closed set of contacts in this normal state right here will have continuity, or there will be a path for electricity to go from this screw to this screw. And then when an object or something would come in contact with the actuator arm, you will see that this plunger here is going to switch. It's going to make contact with the switch, and then now your normally open set of contacts will close. So now there will be a path for electricity to get from here to here, and your normally closed set of contacts would open. So it would open and cut continuity. No more electricity can pass through here. And then to test to see if the contacts are working correctly, I have my meter leads on the normally opens. So right now there's no continuity, and as soon as I actuate the lever, the plunger switches, and now I have continuity. So I know these set of normally open contacts are good. And then down to my normally closed set of contacts, as soon as I actuate this lever, it's going to break continuity, so I know that this bottom set of normally closed contacts are also working. And here I have an example of how limit switches are used in this application here. So this roller table here is going to lift all the way up, and it's using these two limit switches to let the PLC know that it's in the down position or if it's in all the way in the up position. So right now it is in the down position. So you can see that this bracket here is making contact with the lever of this limit switch. So right now the machine knows that it's in the down position. So 24 volts comes into the normally open set of contacts in this limit switch, and then it goes back out to the PLC. It sends that 24 volts back to the PLC, letting the PLC know that it's all the way down. It's using that 24 volts back to the PLC as an input signal to the PLC. And if it would raise all the way up, it would then trigger and actuate the arm of this limit switch. And now it's going to send this 24 volts back to the PLC to let the PLC know that it is all the way up. You can continue with the sequence. If the PLC does not see that 24 volt input signal coming from this limit switch here, it would think that the roller table is not in the down position. So if we would have a board coming up, it would probably stop and it would just stall there. The sequence would not continue until that problem is fixed. Because if the PLC doesn't see that, it would think that it is either up or it is not down. And if they would send the board, it would crash into the table. The board would not make its way and set on the table. So there you have it with this little crash course on limit switches. Until next time, deuces.